look at the proof in front of you, and the first step says diagram as shown, and that's all we are given. So go ahead and fill in the given for that. Then the next thing this proof says is that ABC is a straight angle. How did we get from diagram to just saying that ABC was a straight angle? Who knows? Eric?
You can assume that.
That's something we can assume from the diagram. So we just write assumed from diagram. Then going from ABC as a straight angle, we went that 1 is sup to 2. How do we go from straight to sup? What is the if-then reason for that? Yes?
If an angle is a straight angle, then it is supplementary.
Supplementary. Let's say if two angles form a straight angle. Because it's two angles are supplementary. If two angles form a straight, sorry, there's not a lot of room to write, angle, then sup. Then we kind of have to go back to the diagram. It says DBE is a straight. So that would be the same as step number
3.
No, step number 2. Assuming a straight is assuming from diagram. Then we have 2 sub 3, which would be the same as 3. So if we look at steps 3 and 5 together, we have 1 sub 2 and 2 is sub to 3. What is the theorem that allows us to say 1 is congruent to 3? It's not transitive. Yes.
If two angles are sup to the same angle.
Perfect. The congruent supplements theorem. Write this, please. If two angles, writing, are sup to same angle, then congruent. So what we just did was we proved that this angle here, 1, is congruent to 3. Well, it turns out that 1 and 3 have special names. And the special name for two angles that are on opposite sides of, opposite sides of an x, it turns out that those are vertical angles. And we just proved that 1 and 3 are congruent. So if 1 and 3 are both vertical angles, and 1 and 3 are congruent, then what can we say about all vertical angles?
Vertical angles are congruent.
Vertical angles are congruent. That's the theorem today. Vertical angles are congruent, and it's one of the very few theorems that we do not write out in if-then form. We also know, in looking at this diagram, I don't have them numbered, but angle DBC and angle ABE are also congruent. So if you have two straight lines intersecting, you can assume just by looking at the diagram that vertical angles, angles on opposite sides of an x, are congruent, and your reason would be vertical angles are congruent. If you'd like to say if two angles are vertical angles, then they are congruent, you may. But this is one of the rare exceptions where I don't require you to write that in if-then form. So we can turn this into an algebra problem. If I know that the measure of angle 1 is 2x plus 5, and the measure of the measure of angle 3 is x plus 30, we know that 1 and 3 are congruent. So what can I do with my expressions? Yes. Okay, so.
You can set them equal to each other.
Set them equal to each other and solve. Everybody do that right now.
What's that sign?
This one right here?
Yeah.
It looks like a plus sign. It's got a giant. That's all. So get everything on one side, subtract an x. And we get x is 25. Are we finished?
No.
What's the measure of angle 1? So if the measure of angle 1 is equal to 2x plus 5, we can plug our value of x in. 2 times 25 is 50, plus 5 is 55, so the measure of angle 1 is equal to 55 degrees. And this whole thing would be our answer. All right. Well, if you turn the page to page 33, you can see how we could use vertical angles are congruent in a proof. So So let's look at the first one. And in this first theorem, this first proof, we're given that 2 is equal to 3. Let's go ahead and write that in our proof. Angle 2 congruent angle 3, y given. Well, we can't really assume or conclude anything from angle 2 and 3 being congruent. But look at the diagram. Is there something that we just learned that we can now say just from looking at the diagram? Taylor, take a look at that diagram. Are any other angles congruent? Think about what we just learned today. Diane, what do you think? Which numbers? 1 and 2. Good. Angle 1 congruent angle 2, and here's our rare exception. You just get to write vertical angles are congruent. You do not need to say 1 and 2 are vertical angles assumed from diagram. Okay? Just like when we say if 2 angles form a straight, then they're supplementary. You don't have to say first that the angle is a straight, although we can. All right, so if 1 and 2 are equal, then how do we make the leap that 1 and 3 are equal? Think back to the lesson that we had before retreat when we're combining multiple congruencies. Eric, what do you think?
2 angles.
This isn't going to be an if-then one. It's one of those ones it's just a word. We learned it the day before retreat. You're combined. It's a property. Ah, yes, it's the transitive property. The other one's substitution. So we know it's transitive because we're combining multiple congruencies. So all you have to do here is say transitive property. Substitution would be if you were taking one type of statement, or another type of statement rather, and one congruency and making a sub in. That would be. Well, transitive is a chain of reasoning, right? So 2 and 3 and 1 and 2, therefore 1 and 3. But substitution is, if, for example, if I said angle 1 is sup to angle 2, and that angle 1 is congruent to angle 3, I could sub in angle 3 and replace that angle 1 with angle 3. That's substitution. So that's taking some sort of statement and one congruency and making a substitution. That's what we learned the day before retreat. Here, though, we're combining congruencies. If 2 and 3 are equal and 2 and 1 are equal, we know that 1 and 3 are equal by the transitive property. All right, let's take a look now at the next one, which will actually prove what I just was saying. All right, so go ahead and write the givens, please. Angle 2 is congruent to angle 4. Angle 2 is sup to angle 3. And is there anything from our diagram that we can imply? Because it looks like we're kind of stuck on our givens. Take a look at the diagram. Think about something we learned today. Sorry, I think I need to reset my pen because it's having a mind of its own. Anybody have something they can apply for the diagrams? Maybe something we just learned today? Hint, hint.
Well, 4 is
Transitive.
Not something we just learned today, but nice effort. What do you think?
Angle 1 and 3 are congruent
Oh, yes. How'd you know that?
because they're vertical angles.
Thank you. So angle 1 congruent to angle 3. And then you're going to say vertical angles are congruent. So let's go ahead and mark that. We know that 1 and 3 are congruent. And we also were given that angle 2 and angle 4 were congruent. Well, you guys, if 2 is sup to 3 and 2 and 4 are equal, can't we replace angle 2 with angle 4? Okay. And 2 is up to 3, and we just know that 1 and 3 are equal, so can't we replace angle 3 with angle 1? Yeah. So what are we doing there when we made those replacements? We are making substitutions. So we can say angle 4, sup angle 1, substitution. Nice. All right. Let's just do one more together. Look at, turn the page, let's look at this first one.
Substitution.
All right, so go ahead and write the givens. We're given multiple complementary statements, so in the back of your head you're probably thinking congruent complements. But we don't have anything that says that, we don't have 2 and 3 or 1 and 4 congruent in our givens. So we have to look at the diagram and think, well, what can we imply from the diagram? So look at the diagram and think, what did we just learn today that we could imply?
Vertical.
Oh my goodness, so which angles are you talking about? Which angles are you talking about?
Angle.
Opposite sides of an x, that's what we're looking for.
Angle 3.
Good, so mark those congruent on the diagram and go ahead and say that. Angle 2 congruent to angle 3. And our reason is vertical angles are congruent. So we know that 2 and 3 are the same. So we can conclude that 1 and 4 must also be the same, but who can tell me the property in if-then form? No, no, definitely not transitive.
Oh, if angles are congruent to the same.
Complementary to the same angle. If 2 angles are complementary to congruent angles, then they are congruent. The congruent complements theorem. All right, nice job.